Welcome to EdPsych 501, Screencast 5, Part 2, Non-Experimental Designs. We'll be covering three types of non-experimental designs: causal comparative, correlational, and survey. The characteristics of non-experimental designs are that you are not manipulating any variables. You are observing pre-existing differences on a variable, and it's because you have no ability to manipulate it in one case, or it's unethical to do so. In addition, non-experiments are those in which you do not randomly assign. So there's always that you're starting off with that idea that there could be an alternative explanation to any effect that you find or any relationship that you observe, because you haven't potentially started out with equivalent groups. So we do non-experimental research to describe or to explain. We may be just trying to describe a single variable in detail, or we may be trying to describe the relationships among multiple variables. Or we may be just trying to explain the way the world works based on both kinds of descriptions. The first kind of non-experimental research is causal comparative, and this is an attempt to try and determine causal explanations for differences we see on our variables of interest. But again, we're dealing with the situation where we haven't manipulated, we're looking at pre-existing differences, and we haven't been able to randomly assign. There are three basic types of causal comparative research. The first is where you observe an existing difference on your independent variable, so maybe males and females, for example, and you try to discover the consequences of those differences. So for example, you may be wanting to, in general, want to know the effect of group membership on a dependent variable. So there are some pre-existing groups that exist out there. One of them could be whether or not you attended a charter school. And so you may be interested in, does attendance at a charter school improve educational achievement outcomes? And so you could recruit people into your study who either went to charter schools or did not, and then measure their educational achievement. Or you may get access to data about these kinds of things from the school board. Another type of the first kind of causal comparative research is where you're trying to understand the consequences of an intervention. So this first example question was, groups exist out in the world, they're not really interventions. Down here there are pre-existing interventions that happen out in the natural world. One of them is sex education. Some people get exposed to sex education, some don't. So what are the effects of sex education classes? What are the effects of sex education classes on teenage pregnancy, for example? And so we go out and we recruit people who have received sex education versus people who haven't, and we start to measure all these outcomes around teenage pregnancy. The second type of causal comparative research is where you start with a dependent variable. So you observe a difference on a dependent variable, and you try to identify independent variables that cause that difference. So what are the causes, the independent variable, of group membership? What are the causes of juvenile delinquency? So we know that there are some people out there who you could classify as this, and there are people who aren't. But what leads you to become a juvenile delinquent? What are the causes of variation in quantitative dependent variable? So this is, you're trying to explain why we see differences on intelligence test scores. Why is there differences? What leads to those differences? So the example is, what are the causes of differences in intelligence? So what are the correlates? What predicts differences in intelligence? What sets you up to score highly on a test versus low? The final kind is where you're looking at the effects of variation of a quantitative independent variable on dependent variable. So this is the idea where you've basically got two continuous variables, no categories anymore, whether you're male or female or received sex education or not. This is something where the independent variable is continuous, so it's a spectrum, age or something, and the dependent variable is continuous. It's a spectrum like intelligence. So some examples might be, what are the consequences of differences in the amount of exercise? So we may be measuring a person's level of self-reported exercise, and then also measuring a bunch of quality of life, continuous quality of life indicators. And so we would try to see, does amount of exercise explain some of the variation in quality of life outcomes? So where does causal comparative research fit? Well, typically it's reserved for the situation where you have a categorical independent variable that isn't manipulated. But a lot of people take continuous independent variables, like age, for example, and they create categories based off of them. So you could say, you could create a seniors category. You could create a middle-aged category, a young adult category, a teenage, a youth, and you could categorize based on that continuous variable and then look to see if those categories predict different outcomes. So it's very flexible in terms of how you can use or when you can use it. And it is often done where we've seen a manipulation take place due to policy, and we want to assess whether it's had the impact it's supposed to have had. Okay, so we've talked about the basic types of causal comparative research. Now you've got these causal comparative designs, and essentially the difference between these four designs is that you're either dealing with categorical or continuous variables. Remember that a categorical variable is something where you've got different levels, so you can create groups based off of it. Whereas a continuous variable isn't something you can actually create groups on. It's something that exists on a continuum from, say, 0 to 100 or whatever it might be. And so our primary analytic technique is correlations. And so the first type is between groups designs, and this is where you've got an independent variable or a dependent variable that has different levels that you can create groups with. And that's a simple idea. You would then be looking at the means of the different groups and comparing those means to each other. Then you've got path analysis. This is where you're going to have a bunch of continuous variables, independent variables and dependent variables that are continuous, like age and quality of life, and you're going to calculate correlations among them. But you may have more than just two. You may have three or more. And so you're looking at what is you're trying to describe what is the overall network of relationships. And structural equation modeling is very similar, except it's a more amped up analytic technique. And so you've same situation, multiple continuous variables involved, and you're trying to create a network or understand the network of relationships among these variables. And an archival time series is really just where you have, you're taking advantage of something that happened in time, and there was measures of the outcome variable that you're interested in prior to that event happening, and then there was measures of it after it had happened, and so you're going to look at differences pre and post. The things we have to be worried about with causal comparative is reverse causality, because essentially it could be that the dependent variable is actually the independent variable, or the independent variable is actually the dependent variable, without having established that causal connection where you've randomly assigned. It's very hard to say that this X causes Y. It could be that Y causes X. Then there's the big problem of extraneous variables. We haven't controlled for everything, so there's an alternative explanation out there, unless you employ some very strong statistical controls. So correlational research. This is the world where everything is continuous. Independent variable is continuous, dependent variable is continuous. You're trying to relate two variables together and establish the nature of the relationship, the magnitude of it, the direction of it, and you're trying to essentially just describe the association. We use correlational research to build theories. We use it to understand how things are related to one another. So you may be trying to answer questions like, is creativity, as currently defined and measured, the same or different than the construct of verbal intelligence? So essentially, there's this theory out there that creativity and verbal intelligence are very highly related. And so we might go out and measure it based on current definitions. We would also measure verbal intelligence and establish a relationship. Is it highly positively related? Is there no relationship? Correlational research will tell us. We can also use it to develop models for the prediction of one variable from one or even more variables. So we're trying to do our best at predicting the future. So this is where regression comes in handy. So can we predict first-year grades in university using high school grades and scholastic aptitude test scores? Or can we predict the success of our undergraduate students based on our admissions metrics? And so we will do some regression analyses to see how much of the variation in first-year grades is explained by the set of variables that make up our admissions tools. So there are two tools at your disposal when you're building theories. There's correlation coefficients And these are indices of the strength and magnitude of a relationship between two continuous variables. A visual representation of a correlation coefficient can be achieved by looking at scatter plots. And I've used these throughout my screencasts, where you'll see one measure on the x-axis and another measure on the y-axis, and you see a bunch of dots. And if the dots are looking like there's a strong relationship between them, where one predicts the other, then you're establishing that there's a correlation. One technique that we haven't talked much about is factor analysis. So this is a way of reducing or simplifying a large number of measured variables into a smaller number of underlying factors. So when we built our conservatism, liberalism questionnaire, or we talked about building it, we said there were potentially 3 dimensions. And so factor analysis would be a tool to assess that theory. We would go in and we would take say we created 18 questions, 6 questions for each of the dimensions. And we would run a factor analysis, and we would look for patterns of correlations that suggest the 6 questions that measured personality, conservatism, liberalism go together. We would look for patterns of correlations that suggest that the political questions go together, and finally that the social questions held together. And so it's essentially an analysis where you will look at the patterns of correlations and see how well they group together. And so, of course, it's very useful for validating the understanding or the theory behind a construct that you developed. Okay, so now we're going to move over to the techniques we use to develop models of prediction. And the first one is regression. So in regression, we're trying to come up with a mathematical expression that describes how our independent variable can predict our dependent variable. And if it's simply one predictor and one criterion, or one dependent variable, the model is really just another way of talking about correlation. So this b value here is essentially the same as the simple correlation between these two variables. They also produce something called the coefficient of determination. It's called r squared, which is the square of the correlation. And this tells you how much of the variance in your independent variable how much of the variance in your dependent variable is explained by your independent variable, the percentage. So if you calculate the square of the correlation coefficient, you're going to get a value, and that is the percentage of the amount of the variance in the dependent variable that is explained by the independent variable. Of course, if you're going to do regression analysis, I highly suggest you take another course in multivariate stats, but you should get some pretty good introduction to this from the text. This is where we get into now, what if we had a group of predictors? So instead of one, we have multiple variables that we think predicts our dependent variable. So multiple regression analysis is where we just have more than one predictor that can be added together to produce an estimate of our dependent variable, so a prediction of our dependent variable. Same principles apply. We can have a multiple correlation coefficient, and we can get a coefficient of determination. And the coefficient of determination is, again, how much, what percentage of the variance in the independent variable can be explained by this group of predictor variables. So that was a very brief introduction to those ideas around regression. Read the text. If you're going to be doing regression analysis, take another course on stats. What is survey research? Survey research is really about describing characteristics of variables in populations. So if you have access to the entire population, that's called a census. But typically in research, we're talking about samples, so we're not in that census world. So what kinds of survey research have been described? Well, you've got the single group, single observation design, where you're just focused on an adequate description of the variables of interest in the target population. Then you've got longitudinal surveys designs. This is where you're trying to establish, are there trends in things, where you're following cohorts of people, and you're trying to see, do their outcomes change over time? Where do they go in life after having completed a program? Then there is also the explanatory type of survey. And this is not much different than correlational, to be honest, because you can measure categorical variables, you can measure continuous variables, and then you can start looking at relationships among them. So here are some examples of what might be classified as survey type research. How many graduate students in the Department of Educational Psychology own a tablet? How much time do the graduate students in the University of Alberta spend using their tablet? What are the attitudes of students in EdPsych 501 towards research? Well, there's a loaded question. What are the attitudes of Alberta school teachers towards inclusive education? And the list goes on and on. So this is just single variable survey type research. When you're conducting this type of research, certain issues come into play. You really need to know who you're targeting. So at the outset of your study and your development of your question, you're going to specifically outline who it is you're trying to access. Once you know your target population, you're going to implement techniques to create a representative sample. Rample, that's a spelling error, but a representative sample. If you don't have the ability to randomly select people from the target population, then you're always going to be in a world where you're going to be evaluating how well you represent the target population. So you're measuring demographics, comparing your sample back to the target population demographics in order to say whether or not you've got a biased or unbiased sample. The other issue to take concern of is accuracy of your estimates. So whenever we're calculating means or correlation coefficients or any kind of statistic based on our research, the accuracy of that is based on the sample size that we have in our study. So the more estimates we make, the larger the sample size we're going to need. So if you're assessing a really complex model that has many variables involved, you're going to need a lot more people in your study than if you're looking at the relationship between two things. And so there's some guidelines and guidance about when you need to increase your sample size, and we've talked a little bit about that. So that actually takes care of the non-experimental research designs, and we've covered off all the quantitative research designs. These will be useful for helping you go forward with your methods section as you develop your proposal.